Good evening mga Bisaya. So in this video, we will be discussing um, preparations of structural plans. So we will discuss these two here at the same time, roof framing plans and floor framing plans. And in this video, we will start with concrete framing. So if we will, so this residential building, we will try to do a framing plan first, considering if this is a concrete building or concrete frame. So once you receive the architectural plan, um, so we already discussed about loadings. Like you have to evaluate this one, evaluate the plan. Now in this video, like I said, it will be focused on framing plans. So for example, if this is a concrete building, and our typical construction is we will have columns, and then most likely columns at the corner. And then since this is an opening, so it would be better if you have another column here. And then if possible, you can have column on this side as well. And then next would be somewhere here. I mean, the column locations doesn't have to be aligned. You can have, you can get rid of this column if, for example, there's an opening here, and then that column would affect the what do you call this one, the opening size. So you could do instead, you will like you will offset this one here, or if you want, you can span the whole. So this is 45 feet. So I would say this is around 25, or at least between 25 to 30 feet. So if that's the case, then maybe that's too. I mean, you can design whatever span you want, but it will be really big. So if you want to minimize the size of your structural elements, then you have to add more columns and more beams. Now, this one here, if you notice, there is an opening here. So, um, well, first, what basically what will dictate your um beams beam spacing, column spacing is, first you have to determine what would be your minimum slab thickness. What would be your slab thickness? Now, for example, you will minimize your slab thickness. If I remember correctly, the minimum is 5 inches, and then whatever's the, because there will be calculations, and it should not be less than 5 inches or 125 millimeter. Now, you have to refer to the code. So I have here a screenshot of the provision from ECI 318, and these are the different tables in calculating for the minimum thickness. So, for example, you will have, say, you are limited to a you will limit your slab thickness to 5. So, for example, if you have a one-way slab, then you have simply supported, no, like usually for um, typical construction, you will have beam along edges, so it will be fixed. So you have one end continuous, both end continuous, and then cantilever. So for example, we will have both end continuous. So you will have, or in this case, for example, our slab spans this way. You don't have any intermediate beam in this direction. I mean, you can if you want, but this is only like 25 feet. So how much is that in meters? So like 8 or 7, 7.5, um, like 7.6 meters. So that's long, I think, long span. So you have an option to provide intermediate beams here along this direction in the middle, and then you will have another column here. Now, if you are not allowed to have a column here, then you can have greater beam. Now you have those options. Now, first thing to consider, like I said, is to determine what would be your um, minimum slab thickness, or say, for example, you are like your client, or you know, I mean, you yourself, you would say you would decide my minimum thickness would be 8 inches or 5 inches. Now, if you the way like if you remember, you have two types of slab. You have one way, or we'll go to this slab thickness here. So one way, no, so this is one way slab. Now you have the criteria. So if this is your say width, and then this is your length. Now your L over W is less than or equal. Oh no, this is greater than 2. So if this is the situation, this length is greater than twice the W, then this is a one-way slab. And then, for example, in our discussion, you will have, um, so for example, you have intermediate beam in the middle. You already decided to have that intermediate beam because this is 25 feet. So this will divide that into 2. Then you have on this side, this will be one end continuous. So most likely it will be one end continuous. Now, for example, in this formula here, one end continuous, your minimum H is equal to L over 24, right? So that's L over 24. Now, L in this um, situation, or in this formula, now we will assume that it would be spanning in that direction. So that would be the clear span. That would be the clear span between. So you have your beam here, and then this is your slab. So this would be your L. No, this one here. So that's your L. Now, to see if your L is 25, or let's just say it's we'll reverse the calculation. So you already said, you will use 5 inches. So that means your maximum length would be 24 times 5 inches, which is, that would be 10 feet. So for this to be a minimum of, or for this to be to have like a slab thickness of 5 inches, assuming this is a one-way slab. Now you are only limited up to 10 feet. Now if you look at the sample floor plan, this is 25. That means your clear span would be at least 11, 12 feet. So that exceeds. So to determine the minimum required would be, so you already said, like, your L is 24 feet. So like 5 inches or H would be no, not 24. This will be 12 feet. For example, your clear span is 10 feet divided by 24. That is 0.5 feet or 6 inches. So that means if this is your floor plan, and then you only decide to have one intermediate beam, that means, and then you decide, there will be no cross beam. You will decide that this will be um, this will be one-way slab. Um, if that's one-way slab where your length is more than twice the width, the short span and the long span. So this one is long span, and then this one is short span. So if long span is bigger than twice the width or your short span, that is one-way slab. Now, if you decide to have just a single intermediate beam, that means your minimum slab thickness is 6 inches. Now, if you decide that this will be framed with, this will be like a two-way slab, you will have, um, you will decide that you have beam here and then another beam here, and maybe another beam on this side like that. And then since you have opening, I don't know, it depends. So for example, this whole area is, you will have, you know, the, the stairs going up, then you will have a support beam here like that, and then another beam here. So you can frame it that way. Or if there's a floor here, then you can add another beam. So that will be your framing. Now, for the sake of discussion, so this is 12 and then this is a 25. Or no, because we don't have dimensions. So this is probably 20 and this is 12.5. So that means if this is 12.5 and then there's 20 feet, and then this one here is 25, like total from here up to here, and the total is 45. So for example, this is 20 feet. That means this will becomes a two-way slab because your long span is less than twice the short span. Now, if that's the case, you will go with this calculation here, minimum thickness of non between of non two-way slab with beams. So this one here. So if you have perimeter beams, then this will be your calculations for minimum slab thickness. And then, so you have here alpha FM. This is new. Well, to me at least, at least to me, this is new. This is not the way we calculate um for two slab, like minimum thickness, because this is ECI 318. I think 2014. I think. Um, I think this is 2014 because when I took the licensure exam in the US, that was 2015. I think this is 2014. Um, but when I was still at university, the calculation for slab thickness for two slab, it depends on the perimeter. So you will calculate the perimeter. So this is a different calculation, but the idea is the same. Basically, you have to determine now if you set your or you can check, like for example, you decide 5 inches is the minimum or the maximum thickness that you will use. Then you will check if this is okay, like it will meet these requirements here, or you will get the actual thickness of the slab. So from these calculations, you already have an idea how to frame your building because you are limited. For example, if it's a one-way slab, then you're limited to 10 feet. Now, if you want two-way slab, then maybe with this area, you will be um, what we call this one, it will be okay to use 5 inches, and then it will be a two-way slab, this one. So you can frame it that way. So the same, um, what we call this one here. So yeah, so I think that would be, um, so of course you will have perimeter beam here, this one, um, this one here, right? So yeah, so this will be your framing, and then this one would be open to below because this is your stairwell going, up and down. So assuming this is the second floor for framing plan. So that would be, you know, this will be your framing. Now it is different for the, I mean, well, if you are using a roof deck, then you would follow the same layout, but you won't have this portion here because it's already, or if you are using that as a like the roof deck, you will use the roof deck for, um it will be occupied like for like assembly, then you will have this opening as well going up to the roof deck. But if it's just like a concrete roof, then you don't need these intermediate beams. Now it will be the same. So if we are using a masonry, you know, if you are using a masonry frame, then this will be, um, or masonry wall, like load bearing masonry wall. Then this will be a masonry, like load bearing masonry wall. This entire um, perimeter would be load bearing, and then it will be different. Like the roof joist, usually for masonry, the roof joist could be, or the roof framing could be made up of steel joist, mm, open web steel joist, or open web wood joist. So we will discuss that in another video. We will focus on wood framing, but yeah. So this would be your initial framing layout, and then there will be changes. Like your first layout will not be final. You know, it's more of like a conceptual framing plan at first until you finalize everything. Because sometimes when you run your first analysis, it would end up, the beam is really big, and then most architectural will dictate also the number or the size of your beams and columns for, aesthetic purposes. The architects won't would not like, or yeah, will not like a column that is too big that will encroach the, for example, in this, like I said, in this location here. That's why you could have your column on this side so that this will not be affected, the clearance, the minimum opening width in that area. Otherwise you will have to change the shorten the wall, which is, it will reduce this area. So the best location, if you want to have a column in this area, it would be right here. Now, so once you're done with your conceptual framing plan, and then you run the analysis, now you will end up, say for example, the architect only allow a beam size of, say, um 250 by, you know 250 by 400, and then your column size would be 400 by 400, or 500 by 500. you know now if you end up big having a column more than the requ or the specified, because you have like first once you have the preliminary section sizes of your structural members, you have to discuss with the architect, are you like are we allowed to have a column size this big, are we allowed to have a beam size this big, because you have to consider, the clearances, and then as well as the floor to ceiling height. You also have to consider the floor to ceiling height. Make sure that you have enough clearance, for the ceiling. The typical ceiling height for residential building is 9 feet. Um, eh, yeah, I think 9 feet, 9 or 10. So yeah, I mean it depends on the architect. So if you have, especially if you have intermediate beams, the way we framed earlier, where we have intermediate beams in this direction and then in this direction as well. Now you would end up having a bigger, or you know like especially in this area here, this is an open area. At least on this side you can hide it with the wall, but on this side this is open. Then you will have bulkhead in this area. If you cut section, if you cut section here, that section, then you have your slab here, then the perimeter beam, and then another beam here, like that one. Now, if the architects doesn't like a beam in this direction, then you will be forced to span, you know, um, you will have, at the end of the day, it will be whether you like it or not, it will be the architect who will dictate the framing layout, and then our job as a structural engineer is to make sure that whatever the architect wants, it will work. And then sometimes there will be a compromise if, for example, it will end up really, really, really big. Because what you can do is you can have the architect can say, I don't want any beams in this area, like going here. So I want a flat ceiling. So I mean, you have to satisfy whatever the requirements of the architect, or if especially if that's what the client wants. Then all you have to do is make some compromises. Say if you end up, having, imagine this is your slab, two-way slab, like clear span 25 feet. So you can say, okay, if that's what you want, then I mean in the Philippines, pre-stressed concrete, like hollow core slab is not common, steel joist is common. We always rely on having like a concrete slab construction. Um, this might end up, maybe 10 inches, 12 inches, we don't know. So if you talk to the architect, okay, we can clear this span. We cannot, we won't have any intermediate pin, but this will be the slab thickness. Well, if the clients or the architect approve with that thickness, then yeah, sure, we cannot, um, we can avoid having intermediate beams. Or if you are open, for example, you will do like some kind of like an open web, you know, open web is still joist, but it will be, because we don't have any manufacturer, we don't have any manufacturer for open web steel joist, then we can do some kind of like a built up. It's the same as truss. We will discuss that in other video, in the next video. Um, Open web steel joist, like metal leaking on open web steel joist. We will discuss that in a separate video. This one will just focus on concrete framing. So yeah, so these are our options. If the architect or the client doesn't want any intermediate beam, then this will be a clear span. It will be really thick. 25 by 20. So although the load is only like residential, so that would be 40 PSF plus the partition load of 20 PSF. But like I said, I discussed this in the in the previous video that this calculation was based on a wood framing, so you have to make sure that you accounted for the actual partition loads. I just don't understand why, like back home, we're still using like I would understand why we will use masonry wall in the perimeter in the exterior wall. I understand that we'll use CHB or concrete hollow block or here it's called CME or concrete masonry unit. I understand that because we have, like typhoon. But in the interior, I don't get why we are still using masonry wall. I mean it's just a partition. I mean it's not carrying any load and it will just make your structure heavy. If you remember in our discussion regarding seismic load, our design base here is a is a factor of your building weight. So the heavier the building, then the bigger the base share for your seismic like calculation. So I don't know. I don't really understand um why we are still using masonry unit or concrete hollow block in our partition walls. We can design like I think it's already common like some PVC like wall, or you can have metal stud like hard deflection metal stud light gauge steel as your you know as your non-load bearing um support wall stud, something like that one. But anyway, I mean that's just a I'm just curious why we are still using like concrete hollow block. It's just making your structure heavy, and that would increase the seismic force for your building. So, what else? So yeah, again, I mean, like I said, most of the time it is the architect who will dictate, where your column locations are, what would be the maximum size of your beams, and then it is our job to make sure that it works. Say, for example, if the architect wanted this um, beam span, like clear span, because he doesn't want any column here, like even me. I mean, if this is my house, I won't. I I don't like any columns right here. I would try to have the columns hidden, like at all intersections. So, for example, if this is 20 feet, then you have to design this, regardless of how big it is. I mean, that's where, like I said, when you first start your calculation, you will have like a conceptual framing plan, and then you run your first calculation, and then once you have the result, then talk to the architect. Okay, this is what I got, and then it's up to the architect who will decide. Maybe he can if you decide, or um if for some reason you really need a column in here, then it will be the architect who would decide how to hide that one. But you have to take note that this is a bedroom, and then you are seeing this big chunk of concrete like column there, just eating your area, like room area. So it would be ideal if we will just span beam, like clear this beam so that there's no column here. So I mean, it doesn't matter if for example, if you really want to clear that one, I think it will end up like say 300 by 500. So just discuss with the architect, are you okay with this one? Otherwise we will be adding a column there, so it's more of a like coordination. And then that is part, like when in my one of my videos, I discuss about the role of the architect versus the engineer, then what would be the procedure. I discuss about conceptual layout, conceptual plan, conceptual floor plan, site plan, and it will be submitted for development permit. And then after that, then that is the design phase. like all discipline, structural, architectural, it will be full design, and then that is where coordination happens. Like, you will give the architect, okay, these are the preliminary sizes for structural members. We have to have a column here. This is the size. We have a beam here. This is the size. Now it will be the architect's decision if he wants this or she wants this clear span. If not, then yeah. If the architect wanted to have a smaller beam section, then just tell him or tell her that, if that's what you want, then we have to add column in between. So that is where coordination happen. So um, I think what else? Um, I think that's it. Yeah, I think that's it for now for the steel or for the concrete framing. And then we will in the next video we will discuss this the same building if it is a wood frame and steel frame. Now I have another example here, but this is a large building. This is actually a warehouse. And this building, this was our like one of our old projects in the US. And this is a steel like pre-engineered building, but we will try to lay out this one with wood frame and steel building. Um, the way it is laid out, with fewer columns, I don't think a concrete frame will work on this one. I mean, it can be done. You will have large beam and column like along perimeter, and this can be like hollow core slab. But I myself, I don't have any experience with hollow core slab, so we'll just we will just try to discuss. Anyway, the theory is the same. I mean, the procedures are the same. We will just be framing this one with steel and wood because it is easier. Anyway, I think yeah, that's it for today. See you in the next video.